Okay, for this one right here, we're noticing that it's going from a -4 up to a -3, up to a -2, up to a -1. So hopefully you can see that that's just jumping by +1. And then on the other side, though, did you notice that from here to here, it's up 3? So what's happening this time is we have a 1/3 rate of change. Our slope is 1/3, and it's not multiplying by a third, it's adding 1/3. So the type is linear because it has a constant first difference. And then the recursive goes f of -2 equals -4. And remember that you can use any term. I just like to use that first term. And then f of x equals f of x minus 1 plus 1/3. Now my explicit, let's go do our normal thing and then test it to see if it works. Can we do our usual, begins with something, adding something every time to the something, something, something. Let's try it. Begins with -1, adding 1/3, and then x minus 7. Let's test this out. So this says -1 plus 1/3 x minus 7/3, or 1/3 x minus 10/3, because -1 is like the same as saying -3/3, and -7/3, that's -10/3. So let's go plug in an input from our table and see if it gives us our output. So f of 1 means 1/3 of 1 minus 10/3. That should give us a -3 if this works. So f of 1 equals 1/3 minus 10/3. Well, that equals -9/3, which is -3. And if I look up here, when I plugged in a 1, I got an output of -3, and that's what I'm supposed to get from the table. Let's do another one just to be sure that our explicit is good. Let's test putting in an input of 4. F of 4 equals 1/3 times 4 minus 10/3. So that's 4/3 minus 10/3, which is -6/3 or -2. So when I plug in a 4, I get an output of -2, and check it out, that's what I'm supposed to get looking at the table. So we followed the same rules for the explicit. Begins with what, adding what, x minus what. I used this row right here to write my explicit. Which technically means that I need to switch this dot. So I'm going to use f of 7 equals -1, and then that would apply for the bottom one that I did. So here's my explicit simplified. Here's my explicit unsimplified. Both of those would have worked. How'd you do? Okay, looking at the next one, let's see if this is dividing, or let's see if this is subtracting by a constant rate. So I'm going 28,800 minus 34,560. That's down 5,760. 2,400, 1,000 minus 28,800. That's down 4,800. Oops, it's not a constant. So this is not linear. So let's try dividing. 28,800 So we're going 28,800 divided by 34,560. And I'm getting a 0.83 multiplier. Let's try the next one. 24,000 divided by 2,800. There's that 0.83 again. 20,000 divided by 24,000. There's that 0.83. Now this is a 0.83 repeating. So we're trying to find a fraction that's going to give us that 0.83. And so 4/5 is too small. 4/3 is too big. 3 divided by 5 is 0.6. 5 divided by 6, there it is right there. So if you do 5 divided by 6 on a calculator, it gives you that 0.83 repeating. So 5/6 is our multiplier. So times 5/6 times 5/6 times 5/6. So if you take the 34,560, multiply it by 5 and divide it by 6, you get this next term. If you take the 28,800, multiply it by 5 and divide by 6, you get the next term. Okay, so the type is exponential because it has a common ratio of 5/6. So my recursive goes like this. F of 10, equals 34,560. F of x equals f of x minus 1 times 5/6. And then my explicit goes f of x equals 34,560 times 5/6 to the power of x minus 10. How'd you do? If you put 0.83 repeating in there instead of 5/6, I would take it, but I encourage you to go for the exact answer next time and keep trying until you find that fraction. Okay, we did our linear, we did our exponential, that leaves us our quadratic. Let's see what's happening here. All right, so going from a -1 up to a -16, this is going to be, going down is going to be going down 15. Now, if I'm not good at visualizing that, you can do it on a calculator. You can do -16 minus a -1, and then it gives me that -15. So here I go again with the next one, -41 minus a -3 is going down 38. And then 76, the difference there, $35. Okay, hang on, I did something wrong on this one. -41 minus a -16. Sorry, on this one right here, should have been 25. Okay, notice now it's going from a -15 to a negative 25 to a negative 35. So this is going down 10 as my constant second difference. So my type is quadratic because it has a constant second difference of negative 10. So my recursive, by the way, I'm going to erase this work down here from my explicit work testing, just so I can make space for this answer. Okay, my recursive goes f of 1 equals negative 1. F of x equals f of x minus 1. I need to get that linear rate of change. For my explicit, we start with a base of x squared. We take half of the negative 10. So that's going to be negative 5x squared. And then let's do there's no zero term in the table, so you can build it backwards, or you can just fill the need. So let's check out what we need. So if I were to plug in a 1 squared is 1 times negative 5. When I plug in a 1, I'm supposed to get negative 1 as the output. So if I add 4, negative 5 plus 4, would that give me the output I need? Now let's go test out a similar one. Okay, this time instead of a 1, let's plug in a 2. When I plug in a 2, the output is supposed to be negative 16. Let's go test it out and see if it works. Positive 2 squared would be 4. 4 times negative 5 is negative 20. Negative 20 plus 4 is negative 16. So my input of 1 yielded the correct output. My input of 2 yielded the correct output. I do have my function where I add 4 at the end. And there's my explicit. So let's go do the linear rate of change work up here. Let's use purple. Pick a row, any row. I'm going to go like this. So it begins with negative 35, subtracting 10, x minus 4. We get this negative 35 from right here in the table, that linear rate of change work. We get this negative 10 right here, and then we get the x minus 4 from right there. Let's go simplify. 10x, negative 10x, plus 40, and then combining like terms, negative 35 plus 40 becomes negative 10x plus 5. There's my linear rate of change work. How'd you do?